Hello, everyone. Let's continue our study of cost equivalent cost calculations. That is chapter 6 in engineering economics subject. Okay. So here I have a question. So this is again a practice question similar to what I have done in my previous video. So let's look at this. So here, again, you can pause the video, you can go through the question and you can attempt it. And if it is fine, you can solve it and you can come back and compare your answers with my answers. Okay, so let's look at this question. So you invest in a piece of equipment costing 40,000. So the initial investment is 40,000. The equipment will be used for 2 years. So capital N is 2, worth 15,000 at the end of the 2 years. So salvage value is $15,000. The machine will be used for 4,000 hours during first year and 6,000 hours during second year. So 1 2 usage 4,000 hours and 6,000 hours. So this is the usage of the machine. The expected savings associated with the use of the piece of equipment will be 28,000. So savings $28,000 in the first year, and then $40,000 in the second year. And your interest rate is 10%. Okay, so I equal to 10%. Yeah. So let's continue. So, uh, so we got the savings numbers here. The expected saving associated your interest rate is 10. What is the capital recovery cost? Okay, so the first question A part is capital recovery cost. So there is a two ways to find this. So first I will do the long way. See, just look at only the capital part. Okay, so what I have is 40,000 initial investment, and I have salvage value of 15,000 at the end of the 2 years. Okay. So when if you want to calculate capital recovery cost, so we need to calculate the equivalent cost of this. Okay. So first first I start by finding the present worth. Okay, so what is the present worth? So present worth will be minus 4,000. See here savings I'm not considering. Revenues and savings you don't consider because we are only interested in the cost. So then this 15 is there, right? So I'll go for plus 15. So why plus? Because it is a salvage value, it is a positive. And then here I will say P by F because the future value is given. I want the present value. And interest is 10% and 2 years. So 40,000, 15,000 multiplied by P by F 10%. Okay, so I have the sheet here. So P by F 10% for 2 years, 8264, 0.8264. So now let's calculate. So 15,000 multiplied by 0.8264. So I'm getting 12,396 minus 40,000. So minus $27,604 is the present worth of the project. Just a minute. So let's now after calculating this present worth, here we are. It's strictly not speaking present worth. It is a maybe we can say present cost or something, because we only taken the cost. See, the savings amount we did not consider in this. Now this amount I want to distribute evenly to 1 and 2. Okay, so that means I want to see what is the cost here and what is the cost here because it is anyway negative. So if I want to equivalently distribute, then it is called capital recovery cost. So how I'll get it? I'll just take minus 27604 and then multiply. So I want the annual equivalent A given the P, and it is 10% and it is 2 years. So how do I get this? So here I can refer to this my A by P sheet, and I'll be able to calculate that. Anyway, so I have P by A sheet, so I'll just have to reverse it. So the interest rate is 10%, and here for 2 years 1.7355 is there. So minus 27604 divided by 1.7355. Okay. So I'm not multiplying because I'm referring to P by A sheet, not the A by P sheet, but this is fine. So this value, so 27604 divided by 1.7355. So I'm getting $15,905. So with a minus sign. So this is actually the capital recovery cost, or CR it is called. So that is exactly what is asked in the first question. What is the capital recovery cost? Now there is a direct formula also for this, okay, because it is only standard things are there. The capital recovery cost, the formula is like this. So initial investment minus salvage value, and then this amount has to be, let me just refer to that formula. So A by P, and then whatever I percentage and N years, plus I into S. Okay, salary value. This is the formula. Let us check with formula what we'll get. So I is 40,000, minus S is 15,000. Now A by P, I is 10% and N is 2 years, and then IS. Okay, that is zero point 0.1 into 15,000. So that is nothing but 25,000 multiplied by, right? Now A by P I don't have, but P by A I have, and the value is same, 1.7355. So here I will say 1.7355, then plus, so this will be 1500. Okay, so what I am getting here? So 25,000 divided by 1.7355. So I'm getting 14,405 plus 1500. So that value will be 15,905 dollars. So this I'm exactly getting that the capital recovery I'm getting exactly same what I got here in this process. So this amount, this is exactly same as what I got here. So the two procedures are there. So this is your method one for calculating the this one, and this is your method two. So if you can remember this formula, use it. Otherwise, you can simply make this part. Now let us come to the second part of the question. That is, what is annual equivalent worth? Okay. So here annual equivalent cost we calculated. That is nothing but 15,000. Now annual equivalent worth, I need to consider everything. Okay. So let us do that. So B part, annual equivalent worth. So again, I have see, I have the present worth, right? Present worth is minus 27,604 as the cost. So it's simply that itself I will write, because that will simplify my calculation. See, since already I calculated the present worth of salvage value and initial, so I'll write it here. Then 1 year and 2 year, what are the savings? Okay. So in the first year, the saving is 28, second year saving is 40. So 28,000, and the third year saving is 40,000. Now I will calculate the present worth of all of this. Okay, so again present worth minus 27604 plus 28,000 into P by F, 10% 1 year, right? So plus 40,000 into P by F, 10% 2 years. So that is minus 27,604 plus 28,000 into a factor, 40,000 into the factor. So what are these factors? So already here I have used that factor for 2 years. For 1 year I did not use. So, but anyway, for 2 years I already used. So 0.8264 that is, and this one, let me do that. P by F I have to refer. So let's see P by F. So 10 years. So 0.9091 10%. Okay, so 9091. So now let me calculate this. So I have 28,000 multiplied by 0.9091. So this is 25,455. I'll round it off. Then I have 40,000 multiplied by 0.8264. 40,000 0.8264. 33,056. So this one now I need to find. So plus 25455 minus 27604. So I'm getting $30,907. So this is the present worth of the project, considering everything, considering cost and savings. Whereas the present worth calculated here, it is considering only the cost. So this is the present worth cost. Now, what is the annual equivalence worth? So it's nothing but 30907 multiplied by A by P 10% and 2 years. So that is 30907 divided by 1.7355. So this same thing we have been doing here. So you can see A by P 10.2%. It is divided by 1.7355. So that's what I'll do here. So divided by 1.7355. So I'm getting $17,808 as the annual equivalent worth. So let's continue. So to part C of this problem. So what is the part C of this problem? Net savings generated per machine hour. Okay. So net savings generated per machine hour. That is what we have to find out. See, I already have the annual equivalence worth. Okay. So and I have the present worth also. So now let's say let C be the value of one machine hour. Therefore, what is the value I'm having at the end of the first year and second year? So here, 4,000 hours is in the first year, 6,000 hours is in the second year. So 4,000 into C and then 6,000 into C. So this is my the worth. Okay. So now this present worth, whatever for this, should be equal to the present worth I just calculated. That is 30,907. So therefore, let us find the present worth for this one. So how do you find the present worth? C into 4,000 into this is P by F 10% 1 year plus C into 6,000 into P by F 10% 2 years. Because these are the future values, I want to find the present value. Okay, so that is nothing but C into 4,000 into some factor plus 6,000 into some factor. So what is P by F 10.1? So already we calculated here P by F 10.2 is 0.8264. So 0.8264. And similarly here P by F 10.1 we calculated as 0.9091. Not calculated, we referred 0.9091. So now that we have these values, so let us calculate this. So 4,000 multiplied by 0.9091. So I'll get 3636.4 plus 6,000 multiplied by 0.8264. So I'll get 4958.4. So this is nothing but 3636.4. So 8594.8 into C. This is nothing but the present worth of the project, which is exactly equal to the present worth which we calculated here based on the savings. That is 30,907. So that's what I will write here, 30,907. So from this, I can find the cost per unit. So 30,907 divided by 8594.8. Okay, so this quantity, whatever I have, I will invert it and then multiply by 30907, 3.596. Okay, so $3.596, or you can round off to 3.6 whatever, okay, per hour. So this is the cost of the machine. This is the answer to the third question. That is the third part. Okay. So we have calculated these three parts. So I hope you understood something from this problem. So thank you.